Hey guys, this looks like a fun one. We're given three equal squares, each have an area of 5, and they're packed into this larger square. And it's asking, what is this shaded area? This is day 31 of the 2025 Advent calendar. This is the last one. And if you want to try it on your own, pause it right now, because I'm going to solve it in 3, 2, 1. Since we know each of these squares has an area of 5, the side lengths of the squares are all going to be equal to square root of 5. And that's always true. If you know the area of a square, the side lengths will always be the square root of the area. Here's some notes for that right here. And then we don't know this distance. Let's call it x. This one will be the same as this. It'll also be x. And then this right here will also be equal to x. And then we can cut up the shaded area to be this square and these two triangles. And we can copy it down here. Let's break apart the square and the triangles and let's put labels on everything. This square is going to be x by x. This base of this triangle is going to equal x. And this base of this triangle is going to equal x. And then we can extend this here and then go up to here. And that's going to be the height of our triangle. And if we go up here, we can see that that is the same thing as this square root of 5. So we can plug in square root of 5. And same thing for this triangle. We can extend the base out to here and then drop the altitude to here. This height will be the same thing as this, so it's also square root of 5. If it helps, I can drag this over here and you can see they line up perfectly. This is equal to square root of 5. And now we can rotate these two triangles and let's write a formula for the shaded area. It's going to be equal to this square, which is x squared, plus this triangle, which is 1/2 base of x times the height of square root of 5. And then this triangle has the same base and height, so we can say there are two of these. We can clean this up a little bit. The 2 and the 1/2 can cancel each other out. So we're left with area equals x squared plus x root 5. This looks important. Let's put a box around it. Let's clean all this up and let's move this down here. Next, I want to focus on this triangle here. Let's copy it down here. And let's also copy down this triangle. In this triangle, this angle is equal to 90 degrees. And in this triangle, this angle is equal to 90 degrees. And then these two red angles are also going to be congruent because they are vertical angles. And anytime you have two triangles with two pairs of congruent angles, the two triangles are similar. So we can write a proportion with the corresponding sides. First, we got to find the sides. This is the same as this, so it's square root of 5. And this is this one, which is equal to x. And then this is a side of this square, so it's also square root of 5. And this side is the same thing as this x plus the root 5. So it's going to be equal to x plus root 5. And now we can rotate the triangles and let's fill out this proportion. It's going to be the height over the base equals the height over the base. Root 5 over x plus root 5 is going to be equal to x over root 5. And then I ran out of room. Let's bring this up here. To solve this, we can cross multiply. It'll be x times x plus root 5 equals root 5 times root 5. And then on the left-hand side, this x can distribute to each of these, giving us x squared plus x root 5. And on the right hand side, root 5 times root 5 is equal to 5. So now we have x squared plus x root 5 is equal to 5. But x squared plus x root 5 is also equal to our area. So in the place of this, let's substitute 5. Let's give it a label of square units and tighten the box. And this is the answer to our question. In this given diagram, with each of these squares having an area of 5, area of this region will also equal 5. How exciting. And that is the end of the 2025 Advent calendar. It was way more challenging than I expected and took me longer than I planned, but we did it. And now that Advent is all wrapped up, I have free time to finish some lessons on Brilliant. I'm currently in the middle of this course on circuits. I never really learned about circuits in school. I touched on them briefly in an engineering course and a little in calculus, but I basically forgot everything. What's been really interesting to me is the importance of the path of least resistance and how that applies to everything. It seems kind of intuitive, but I understand it much better now that I've gone through the course. I also like how voltage, current, resistance, and power are all related to each other mathematically. I'm still figuring it all out, and that's part of the fun. For me, Brilliant is a nice escape from the chaos of the real world. You can tell that every lesson is carefully crafted by experts. World-class teachers from MIT, Harvard, and Stanford. I always look forward to seeing what journey they're going to take me on today. It's so much better than watching a video. I actually get to interact with the lessons, and I don't move forward until I know know I understand. If you want to try Brilliant for free for a full 30 days, visit brilliant.org/andymath, scan the QR code on the screen, or click on the link in the description. If you use this link, Brilliant is offering 20% off an annual premium plan. That'll give you unlimited daily access to everything Brilliant has to offer. How exciting.